Very interesting question. A jet of an enemy is flying along the curve jet plane. Okay, a jet of an enemy is flying along the curve y is equal to x square plus 2. A soldier is placed at the point 3, 2. Now suppose a plane is moving like this one and a soldier is sitting with the anti-aircraft one. At what time he should shoot to the plane, and what the time will be, at what time he can shoot it, at when the distance of the plane and the soldier is nearest, okay, is the least one, then only he can shoot it. Okay, so that's what the question is. Okay, a soldier is placed at the point 3, 2. What is the nearest distance between the soldier and the jet? Okay, so let's make it suppose we are having a jet is flying in this way. Okay, and equation is given y is equal to x square plus 2. This is the equation, y is equal to x square plus 2. Suppose at this time, now let's assume this is the point which is the least one. Okay, suppose this point is A and the coordinates, let it be h comma k. This is the position of the soldier S, and it is given that this is 3, 2, and this distance from this jet plane, suppose here it is jet plane. Okay, so this, let this distance be z between soldier and a plane. Okay, now let's solve it. Let the position of jet plane on a curve y is equal to x square plus 2 is A with coordinates h comma k and position of soldier S is 3, 2. Okay, now we are having the position of jet A h comma k lies on the curve. Therefore what we can write it? H and k, h is x and k is what? Y. Okay, we can write it k is equal to h square plus 2. Okay, now after this part, because this point A is on this curve, so h and k are the coordinates, so we can put h and k for x and y. Now we are having let this be number 1. Let z be the distance between jet A and soldier S. Okay, so by the distance formula what we are having, we can write it z is equal to, now it is distance, we can write it as AS, distance between A and S. Okay, so ZAS is equal to, now distance formula what we are writing, h minus 3 whole square plus k minus 2 whole square, because soldier S is 3, 2. Okay, so what we have done it, using distance formula. Now let's play a small trick for this solving this question. Okay, let's see it how I am just converting instead of two variables to one single variable. Okay, so we are having now z is equal to under the root h minus 3 whole square plus h square whole square. Now dear guys, from where I got this one? This one I got it using 1. Now what I have used, just check it. I have used it. We are having now k minus 2 is equal to h square from this one. So in place of k minus 2 we have done this one. Okay. So we are getting now, we can write it z square, squaring both sides. Z square is equal to h minus 3 whole square plus h4. Okay. So now if we have to further, we can just expand it. Okay, let's expand it so that we can for the differentiation part it will become easy. Now we are having h4 plus h square minus 6h plus 9. Now differentiating with respect to h, d by dh of z square. So we are not going to differentiate this one, but if you are differentiating this one, just let's check it what you are going to do. If you are writing it 2z for z square, you are writing it after differentiating 2z, it hardly matters. Okay, when you are double derivating it, it will become 2z. Now here when you are differentiating, we are writing d by dh of z. So when you are double differentiating this one by the product rule, then in one of the part we will be getting dz by dh whole square, and dz by dh we are taking for maximum and minimum, that is equal to 0. So it will be coming to the same position. Okay, so don't waste the time, directly just write it d by dh of z square. Now what we are getting? 4h cube plus 2h minus 6. Okay, so let's make a factor. Now we are getting it is equal to 4h cube minus 1 plus 2h minus 1. Now what I have done it? I have just split this minus 6 with minus 4 and minus 2. So 4 I have taken common, so we are getting this thing. And again to this part we can get this one as h minus 1 with 2h square plus 2h plus 3. Now for maximum or minimum value, dz square upon dh is equal to 0. Therefore, now we are having h minus 1 is equal to 0 or h is equal to 1, one thing, and 2h square plus 2h plus 3 is equal to 0, and here we will be getting imaginary roots. Okay, so we are not considering this part. Okay, so this part we are doing? Rejecting. Now we are having h is equal to 1. Now double derivative, differentiating again and putting h is equal to 1 directly. Now what the result will be? We are double differentiating this one, we will be having, okay, let me don't miss the step. So it will be 12h square plus 2. Okay, and when we are taking double derivative for h is equal to 1, we are getting the result as 14. 12 plus 2, that is 14. Now this is greater than 0, therefore distance between jet and soldier is minimum. One thing. Now what are the coordinates for the jet? Now we are having, when h is equal to 1, then k is equal to, now where is k? H is equal to 1, then we are having k is equal to h square plus 2. So k is equal to 1 plus 2 is equal to 3. So coordinates of jet is a with 1, 3. Now last thing is distance. Now distance between, so minimum distance, let us write it, minimum distance between jet and the soldier is as. Now it is what? 1 minus 3 whole square plus 1 minus 3, because we are having 1 3 and 3 2. Okay, don't be confused that I am just subtracting 1 minus 3. Okay, 1 minus 3 and 3 minus 2. Okay, and on solving we are getting as root 5 units, whatever the units are. Okay, so now what we have got it, one thing, first of all we got this part, then we got this one, h is equal to 1, we got this one, double derivative greater than 0 for the minimum part, then we got the coordinates, and finally we got the result. So this is the answer.